Red Hat Clustering. Red Hat Cluster Suite Overview. Clustered system provide reliability, scalability, and availability to vertical production services. Using Red Hat Cluster Suite, you can create a cluster to suit your needs for performance, high availability, load balancing, scalability, file sharing, and economy. This chapter provides an overview of Red Hat clusters with components and functions and consists of the following sections. First, cluster basic, Red Hat cluster suite introduction, cluster interface structure, high availability service management, Red Hat global file system, cluster, logical volume manager, global network, block device, Linux virtual server, cluster administrators tools, Linux virtual server administration. Cluster basic. A cluster is two or more computers that work together to perform a task. There are four major types of clusters. First, storage cluster. Second, high availability cluster. Third, load balancing cluster. Fourth, high performance cluster. Storage cluster provide a consistent file system image across server in a cluster, allowing the server to simulation, read and write to a single share file system. A storage cluster storage administration by limiting the installation and patching of application to one file system. High availability cluster. High availability cluster provide continuous availability of service by eliminating single point of failure and failing over service from one cluster node to another in case a node becomes interrupted. Load balancing cluster. Load balancing cluster dispatch networking service requests to multiple cluster nodes to balance the request load among the cluster nodes. High performance cluster. High performance cluster use cluster nodes to perform correct calculation. A high performance cluster allow application to work in parallel, therefore enhancing the performance of the applications. Red Hat Cluster Suite Introduction. Red Hat Cluster Suite is an integrated set of software components that can be deployed in a variety of configurations to suit your needs for performance, high availability, load balancing, scalability, file sharing, and economy. Red Hat Cluster Suite Introduction. Cluster interface structure. Red Hat Cluster Suite cluster interface structure provides the basic functions for a group of computers to work together as a cluster. Once a cluster is formed using the cluster information structure, you can use other Red Hat clustering suite components to suit your clustering needs. Cluster management. Cluster management manage cluster querying and cluster membership. Performs cluster management in a Red Hat cluster suite for Red Hat Enterprise Linux 5. CMAN is a distributed cluster managed and runs in each cluster node. Log management. Log management is a common cluster interface structure service that provides a mechanism for other cluster interface structure components to synchronize their access to shared resources. Fencing is the disconnection of a node from the cluster's shared storage. Fencing cut off from shared storage, thus ensuring data integrity. The cluster infrastructure performs fencing through the fence daemon fenced cluster configuration system. The cluster configuration system manages the cluster configuration and provides configuration information to other cluster components in a Red Hat cluster. CCS overview. The other cluster components access configuration information from the configuration file through CCS. Accessing configuration information.
Thank you. I am MGI Sevandi. 1.4 High Ability Service Management. High Ability Service Management provides the ability to create and manage high ability cluster service in a Red Hat cluster. The key components for high ability service management in a Red Hat cluster are gmanager implements called failover for off-the-shift applications. 1.5 Red Hat Global File System. This section provides an overview of Red Hat Global File System. Two global file systems are available with Red Hat Cluster Suite, GFS and GFS2. 1.6 Cluster Logical Volume Manager. The Cluster Logical Volume Manager CLVM provides a cluster-wide version of LVM2. CLVM provides the same capability as LVM2 on single node, but makes the volumes available to all nodes in a Red Hat cluster. The logical volumes created with CLVM make logical volumes available to all nodes in the cluster. The key components in CLVM is CLVMD. CLVMD is a daemon with provide clusters extensions to the standard LVM2. Toolset allows LVM2 commands to manage share storage. CLVM requires minor chances to wide looking. You can see this picture. 1.7 Global Network Block Service Device. Global Network Block Device GNBD provides block device access to Red Hat global file systems over TCP/IP. GNBD is similar in concept to NBD. However, GNBD is GFS specific and targets only for use with GFS. You can see figure 1.15 GNBD overview. 1.8 Linux Virtual Server. Linux Virtual Server is a set of integrated software components for balancing the IP load across a set of real server. LVS runs on a pair of equally configured computer. On that is an active LVS router and one that is a backup LVS router. The active LVS router serves two rules: to balance the load across the real servers, to check the integrity of the service on each real server. The backup LVS router monitors the active LVS router and take over from it in case the active LVS router fails. Thank you.
Hello everyone, I am Nimisha Prasansani. I am going to start our group presentation. Cluster Administration Tools. Red Hat Cluster Suite provides a variety of tools to configure and manage your Red Hat cluster. This section provides an overview of the administration tools available with Red Hat Cluster Suite. First one, Conga. Second one, Cluster Administration GUI. Third one, Command Line Administration Tools. Conga. Conga is integrated set of software components that provide containerized configuration and management of Red Hat cluster and storage. Conga provides two following major features: one web interface for managing cluster and storage, automatic development of cluster data and supporting package, easy integration with existing clusters, no need to re-authenticate, integration of cluster status and logos, fine-grained control over user permissions. This is Lucy Home Base tab. This one is Lucy Cluster tab and Lucy Storage tab. Cluster Administration GUI. This section provides an overview of the system config cluster. Cluster Administration graphical use interface available with Red Hat Cluster Suite. The GUI is for use the cluster integrate and the high availability service management components. The GUI consists of two major functions: this cluster configuration tools and the cluster status tool. The cluster configuration tool provides the capability to create, edit, and propagate the cluster configuration file. The cluster status tool provides the capability to measure high availability service. The following sections summarize those functions. Section 1.9.2.1 Cluster Configuration Tool. Section 1.9.2.2 Cluster Status Tool. This is Cluster Configuration Tool. The Cluster Configuration Tool provides the capability to configure, provide resources. Also, a provide resources is a resource that the configured for as with only one service. You can figure provide resource within a service component in GUI service. For creating and configuring high availability service, a service is configured by assigning resources, assigning a favor domain, and define a recovery policy for the service. Services are represented as subordinate element under service. Using configuration button is at the button the right flame. You can create service. This is Cluster Status Tool. Cluster Status Tool. The nodes and service displayed in the cluster status tool are defined by the cluster configuration file. Command line administration tool. In addition to Conga and system config cluster administration GUI, command line tools are available for administrating the cluster interpreter and the high availability service management components. The command line tools are used by the cluster administration GUI and int subscript supplied by Red Hat Table 1.1. Command line tools summarize the command line tools. This is command line tools. Compatibility hardware. The information about hardware that is compatible with Red Hat Cluster Suite components.
Server. Linux Virtual Server is a set of integrated software components of balancing the IP load across a set of real servers. Linux Virtual Server runs on the pair of equally configuration computer on that is an active Linux virtual router and one that is a backup Linux virtual router. The active Linux virtual router serves two roles: to balance the load across the real server, to check the integrity of the service on the each real server. The backup Linux virtual router monitors the active Linux virtual server router and takes over permissions cache the active Linux virtual server router provide an overview of the Linux virtual server component, their interface. Two-tier Linux virtual server topology shows a simple Linux virtual server configuration consists of two-tier LVS router and real servers. The LVS router tier consists of one active Linux virtual server router and the one backup Linux virtual server router. The real server tier consists of real servers connected to the private network. Each Linux virtual server router has two network interfaces, one connected to a public network and one connected to a private network. A network interface connected to each network allows the Linux virtual server router to regulate traffic between silent on the public network and the real servers on the private network. The active Linux virtual server router uses network address transaction to direct traffic from the public network to real server on the private network, which the turn provide service are requested. The real server passes all public traffic throughout the active Linux virtual router. From the perspective of silent on the public network, the Linux virtual server router appears as one entity. Two-tier Linux virtual server topology. Three-tier Linux virtual server topology. Routing methods. You can use network address transaction routing or direct routing with the Linux virtual server. The following selection briefly describe NAT routing and direct routing with LVS. NAT routing. Illustration Linux virtual server using NAT routing to move requests between the internet and private network. Direct routing provides the increased performance benefit compared to NAT routing. Direct routing allows the real server to process and route packet directly to a requesting user rather than passing outgoing packets throughout the Linux virtual server router. Direct routing requests the possibility of network performance issues by relegating the job of the Linux virtual server router to processing incoming packets only. Persistence and firewall marks. In session situation, it may be desirable for the silent to reconnect repeatedly to the same real server rather than have an Linux virtual load balancing algorithm send the request to the best available server. Example of some situation including multi-screen web forms, cookies, SSL, and FTP connection. In those cases, a silent may not work apparently unless the transaction and beginning handled by the same server to return consent. Linux Virtual Server provides two different features to handle this presentation and firewall marks. Persistence. When enabled, persistent acts like a timer. When a silent connected to the server, Linux Virtual Server remember the last connection for the specified period of time. If that same silent IP address connected again with the period, it is sent to the same server in connected to previously. Bypassing the loading balancing mechanism when connected version outside the time balancing windows, it is handled according to the scheduling rules in place. Persistence also allows you to specify a subnet marks to apply to the silent IP address. Test as a tool for controlling what address have the highest level of persistence. Thereby a grouping connected to the subnet grouping connected designed to different ports can be important for protocol that use more than one port of communicate such as FTP. However, persistence is not the most efficient way to deal with the problem of grouping together connected decision for different ports. For this situation, it is be the use firewall marks. Firewall marks. Firewall marks are an easy and efficient way to the group port used for the protocol or group of related protocols. The IP address on Earth 1 and has the plot in IP address allocated to the Earth 1 in the event of failure. The virtual interface facing the internet and the private facing virtual interface are taken over by the backup LVS router simultaneously. Direct routing. Direct routing provided increased performance benefit compared to NAT routing. Direct routing allows the real server to process and route packets directly to the requesting user rather than passing outgoing packet throughout the LES router. Direct routing requests the possibility of network performance issues by relegating the job of LES router to processing incoming packet only. LES Linux Virtual Server implemented with direct routing. In a typically direct routing LES configuration, an LES router requests incoming server requested to a virtual and use the scheduling algorithm to route the request to the real server. Each real server process requested and send response directly to silent. Bypassing the LVS router, direct routing allows the scalability in that real server can be added without the added burden on the Linux virtual server router to router outgoing packet from the real server to the silent, which can become bottleneck under heavy network load. While there are many advantages to using direct routing in LVS. There are limitations. The most common issues with direct routing in LVS is the address route resolution protocol. Firewall marks are an easy and efficient way to the group port used for the protocol or group of related protocols. For example, if Linux virtual server is deployed to run an e-commerce site, firewall mark can be used to ban HTTP connection on port 100 as scale. HTTP connection of the port 100 by assisting the same firewall marks to the virtual server for each protocol. State information to transaction can be previous because the Linux virtual server router forward all requests to the same real server after connected is opened. Because of its efficiency and ease of use, administrator of Linux virtual should use firewall marks instead of persistence wherever possible for grouping connection. However, you should still and persistent to the virtual server in the conjunction with the firewall marks in ensure the silent are reconnected to the same server for an adequate period of time. Two-tier Linux virtual server topology. Two-tier Linux virtual server topology shows a simple Linux virtual configuration consists of two tiers: Linux virtual server router and real servers. The Linux virtual server router tier consists of the one active LVS router and more backup LVS router. The real server tier consists of real server connected to the private network. Each LVS router has two network interfaces, one connected to the public network and one connected to a private network. A network interface connected to each network allows the LVS router to regulate traffic between silent on the public network and the real server on the private network. Three-tier Linux virtual server topology. Three-tier Linux virtual topology shows as a typically three-tier Linux virtual configuration. In the example, the Acrono LVS router routes the request from the public network to the second tier real server. Each real server accesses a shared data source of the Red Hat cluster in the third tier over the private network. Routing method. In the example, there are two NIC in the active LVS router. The NIC for the internet has the real IP address on Earth 0 and has the floating IP address associated to the
1.10 Linux Virtual Server Administration GUI. This section provides an overview of the LVS configuration tool available with Red Hat Clustering. The Piranha configuration tool. The Piranha configuration tool is a web browser graphical user interface GUI that provides a structured approach to creating the configuration file for LVS /etc /ha/lvs.cf. To access the Piranha configuration tool, you need the Piranha GUI service running on the active LVS router. You can access the Piranha configuration tool locally or remotely with a web browser. You can access it locally with this URL. You can access it remotely with either the hostname or the real IP address followed by 3636. If you are accessing the Piranha configuration tool remotely, you need an SSH connection to the active LVS router as the root user. 1.10.1 Control Monitoring. The Control Monitoring panel displays runtime status. It displays the status of the pulse daemon, the LVS routing table, and the LVS spawn nanny processes. This is the figure of 1.27, the Control Monitoring panel. 1.10.2 Global Settings. The Global Settings panel is where the LVS administrator defines the networking details for the primary LVS routers, public and private network interfaces. This is the figure of 1.28, the Global Settings panel. 1.10.3 Redundancy. The redundancy panel allows you to configure of the backup LVS router node and set various heartbeat monitoring options. This is the figure of 1.29, the redundancy panel. Redundant server public IP. The public real IP address for the backup LVS router. Redundant server private IP, the backup router's private real IP addresses. The rest of the panel is related to this virtual server. Complete this page and click on the Accept button. Name. A descriptive name to identify the virtual server. This name is not the host name for the machine, so make it descriptive and easily identifiable. You can even reference the protocol used by the virtual server, such as HTTP, application port, the port number through which the service application will listen. Protocol provides a choice of UDP or TCP in a drop-down menu. Virtual IP address, the virtual server's floating IP address. Virtual IP network mask, the net mask for this virtual server in the drop-down menu. 1.10.4.2 Real Server Subsection. Clicking on the Real Server Subsection link at the top of the panel displays the Edit Real Server Subsection. It displays the status of the physical server host for a particular virtual service. This is the figure of 1.32, the Real Server Subsection. 1.10.4.3 Edit Monitoring Scripts subsection. Click on the Monitoring Scripts link at the top of the pages. The Edit Monitoring Scripts subsection allows the administrator to specify a send except string sequence to verify that the service for the virtual server is functional on each real server. It is also the place where the administrator can specify customized scripts to check services requiring dynamically changing data. This is a figure of 1.34, the Edit Monitoring Script subsection. 2.1 Cluster Components. Table 2.1 Red Hat Cluster Suite Software Subsystem Components summarizes Red Hat Cluster Suite components. A cluster is a group of independent computers working together. When you use cluster configurations, you enhance the availability of your servers. Clustering allows you to join 2 to 4 Windows servers or nodes using a shared disk subsystem. This provides the nodes with the ability to share data, which provides high server availability. 2.3 Compatible hardware. For information about the panel is for configuring the heartbeat channel, which is used by the backup node to monitor the primary node for failure. Heartbeat interval seconds sets the number of seconds between heartbeats, the interval that the backup node will check the functional status of the primary LVS node. Assume dead after seconds. If the primary LVS node does not respond after this number of seconds, then the backup LVS router node will initiate failure. 1.10.4 Virtual Servers. The Virtual Servers panel displays information for each currently defined virtual server. Each table entry shows the status of the virtual server, the server name, the virtual IP assigned to the server, the net mask of the virtual IP, the port number to which the service communicates, the protocol used, and the virtual device interface. This is the figure of 1.30, the virtual servers panel. Each server displayed in the virtual servers panel can be configured on subsequent screens or subsections. To add a service, click the Add button. To remove a service, select it by clicking the radio button next to the virtual server and click the Delete button. To enable or disable a virtual server in the table, click its radio button and click the Delete button. After adding a virtual server, you can configure it by clicking the radio button to its left and clicking the edit button to display the virtual server subsection. 1.10.4.1 The virtual server subsection. The virtual server subsection panel shown in figure 1.31. The virtual server subsection allows you to configure an individual virtual server. Links to subsections related specifically to this virtual server are located along the top of the page. But before configuring any of the subsections related to 2.3 Compatible hardware. For information about hardware that is compatible with Red Hat Cluster Suite components, for example, supported fence devices, storage devices, and fiber channel switches, refer to the hardware configuration guideline at http://www.redhat.com/cluster suite hardware. Thank you.